right, well, happy Thursday. We're going to talk about the final project today, believe it or not. We have a month left to class. Right? We are going till the 23rd. Okay, I had that wrong, 23rd. Online website, 23rd. Or Tuesday, 8 a.m. Okay. Is that what that was? Dearborn exam schedule. Let's Google. For winter. Let's make sure we got the right one here. So if our class meets Tuesdays at 9:30, we're block E, right? Exam code E. And E is Tuesday the 23rd at 8 a.m. Okay. I had it right in the syllabus. I usually try and double check that stuff, but sometimes I get that off, so. All right. 2024 final project. Plus. All right. Repository and include self-assessment using the rubric. Screenshots in the README. All right, so if you want to work in pairs, you're up for it. I thought we had to, my apologies. I'd recommend it, but you don't need to. I suppose if we're not recording it. We are going to build a blackjack something here. So we're going to do this in a couple steps. So part one is setting up all the classes we need to play blackjack. So blackjack's a card game. I love cards. Cards are a lot of fun. This is a very popular casino game because it makes casinos money, like all games that they have there. Casinos don't offer games that don't make them money because that wouldn't make any sense, right? So lots of different variations. We're going to try and go mostly simple-ish here. There's a couple advanced things we're going to skip, which will just make life a little easier here. So when you play blackjack, it's made up of multiple decks of cards. So generally somewhere between 6 and 8. So we'll just go with 6. You'll put them all together and they call it a shoe. I don't know why. But you put 6 decks of cards all shuffled together in a shoe. And then if it gets to somewhere, we'll say like less than 100 cards left, they will reshuffle the deck. So they don't want to go through all of the cards in the deck because that would give players too much of an advantage. Turns out if you know what cards are left in the deck, you can change your betting strategy and possibly win more money. Interesting things here. So part one is just making the classes so that I've got all the different things I need to play blackjack. Part two is we're going to use those classes and use user input and assume that every hand is worth $1 and let someone play manually. So the classes need to be designed in a way that I can play the game manually if I have something that does some user input somewhere. Right? So I need to be able to make a hand, I need to be able to do the things we do in blackjack. So when you play blackjack, it's blackjack online free. Definitely make sure it's free. Probably not one of the casino sites. Free games, probably this is better. So the goal here is you are playing to beat the dealer. The dealer plays against all the players all at once. So we're just going to do one player and one dealer. That makes life easy. We don't need to have multiple players. The goal is to get a higher total hand value than the dealer. That's how you win without going over 21. If you go over 21, you immediately lose regardless of what the dealer does. So that's the house's advantage. That's the dealer's advantage, is players can lose without them doing a single thing. That's how they make their money. So when we deal 2 cards, wow, that's loud. We get 2 cards, the dealer gets 1. You only know what one of the dealer's cards are. Right? So right now our total hand value is going to be 17. So face cards are worth 10, aces are worth 11 or 1. It's almost always worth 11, but if you were to go over 21, you'd want to say, hey, I really want to count that ace as a 1 instead. So there's a little bit of logic we have to track. We're dealing with our cards there. And then the dealer will always keep taking cards until they get to 17 or higher. So if they have 16 or less, they will always take another card and take another card and take another card until they get to 17 or higher. So the dealer will stop at 17, at 18, at 19, at 20, and at 21. So there's 5 values the dealer will stop at. out of all the possible hands, right? Excuse me. So the lowest hand the dealer could have is 4, is 2 2s, right? Going all the way up to, they could start with a 21. Essentially, when they have their 2 cards, you can get 21 with just 2 cards, with an ace and a 10 value card. The kings, the queens, the jacks, and the 10s. Right? All the other cards are just worth their points. So 8 is 8, 7, 7, and so on. So you could decide what you want to do. So for our purposes, we're only going to deal with stand and hit. There's a way to split. There's a way to do a 2x bet. Don't worry about any of those sorts of things here. We're just going to do a hit means take another card, and stand means I'm done taking cards. So if you see that the dealer has an 8, you know in the deck here that because 4 of the 13 face cards are worth 10 points, there's a lot more cards worth 10 than there are any other value, individual values, right? So if you think about if they have an 8, they're likely to possibly get a 10. So a decent chance of them getting a 10, right? 4 out of the remaining 13, so like about a third-ish, a little less than a third-ish, right? 4 out of 13 if we talk about fractions. So 1 in 3 times they'll get a 10-ish, and then they'll be at 18, and they will beat my 17, which is a little bit sad. But there's a chance they might not. So I'm just going to hit and see what happens. Right, so they went from 8 to 13 to 16, and they had to keep taking cards. They got it right, so they busted. They went over 21. We did not go over 21, so we win. So we won that hand. So we won our dollar bet. Let's try again. So we'll play again. Now we have 19. It's pretty good. They are showing a 10. We'll just stay here again. We don't want to take a card. They got another 10, so they beat us. Their value is higher than ours. Right? Now we have 8. So now we want to take another card. 8 is you can always take another card at 8. Right? There's no way to lose taking another card at 8. So definitely want to take a card. Now we have possibly 19. It could also be 9 if we wanted. So we could take another card, but 19 is pretty good, but they have a 10 showing. They might get to 20. I don't know, we'll take another card and see what happens. All right, now we're at 13, we'll take another card. 18, that's getting risky, we'll just stop. Hey, we tied. So if you tie, you just get your money back. You don't lose any money, you don't win any money. So that's the basics for blackjack, right? Trying to beat the dealer's value without going over 21. So we build out our game here. We'll let them just, don't worry about the betting different values, we'll just assume every hand is $1 here. We're going to track how much they win or lose. Okay, it's possible to win money, but on average you lose money when you play blackjack. Right, that's part 2. So that's using these classes. Part 3 is we're going to build a result table to show what is a good strategy for losing the least amount of money here. So for each of our starting hand values, we're either going to hit or stand. Randomly, we'll pick a hit, we'll pick a stand, and we'll see what happens. So if I had 17 and I stood, what happens? If I had 17 and I hit, what happens? So we should be able to get a result saying, okay, here is all of my starting hand values, and then for each starting hand value, and then this is for the player and the dealer. We're going to track the results. So at the end here, so if you look up just blackjack odds on Wikipedia, they show you a basic strategy. Here it is. So the dealer's face-up card is 2 through ace, the dealer card we see. In the real game, they actually have 2 cards. One of them is just face down. It doesn't matter for our purposes. It's probably harder to do it that way. And then this is the player's hand total. So between 18 and 21, you should just do nothing. You should stand. When you have 17, you should stand. The US, don't worry about that. We're not going to deal with surrender. Otherwise, you would stand. You just stand. So are the odds that they're showing us here, or they're telling us the strategy should be to stand. Now, we don't know what the odds are. So what we're going to build out is, okay, if you're at 17 and you hit, here's how often you win, here's how often you lose, here's how often you draw. Right? You'll see more often you win, right, than lose by standing. You should see when you hit, you will lose more often than when you stand. Right? When we generate all these odds, when we simulate playing, we're going to simulate 100,000 times. So using the classes we wrote, we need to also be able to play it automatically with a random, half the time we'll pick hit, half the time I'll hit stand, and I have to track all that information here. right, to see what happens, win, lose, or draw for each result here. So if we do this 100,000 times, we'll get a pretty good distribution of all these possibilities here, right? Because there's 1, 2, 3, I can't, this is just 10 possible values for the dealer face up, right? And then we've got, starting at 4, the pairs, don't worry about pairs, so you can split cards. We're not going to deal with the split rule either. So we'll just have values 2 through 21. I'm sorry, 4 through 21. So whatever that works out to be, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 18 possible starting hand values, right, across 10 possible dealer face-up cards. So it's, what, 180 possible starts. That sound right? And if we do this 100,000 times, we should get a decent number of each of those. So 100,000 times divided by 180 is about 550 of each. And if we're just randomly picking hit or stand, we'll probably get about 250 hits, 250 stands or so, because it's random. So our results then should be, out of the 250 whatever-ish times we stood, how many do we win, lose, and draw? Out of the 250-ish times we hit, how many times do we win, lose, and draw? And we're going to be able to spit all that data out and show people, hey, this is why the good strategy is to stand when you have 17. When you have 16, most of the time it's a good strategy to stand if the dealer has a less than 7 card. Because if they have a 6 or 5, 4, 3, or 2, the odds of them getting a 10 and then having to get more cards, there's a chance they will bust. If they have a 7 showing, they might end up with a 17, like a third of the time, and then if we stopped at 16, we're likely to lose. Right? So a lot of times they'll just get to 17, 18, 19, 20, or 21 here. So it's a generally better chances for you to win if you hit when you have 16, if they have a 7 or higher. We want to stay if they have a 6 or lower. Again, we're going to generate all the odds to see what did happen when we played our simulation here. What does that look like? So this is the strategy. We're not actually building the strategy. All we're doing is calculating all the odds so that if we were to look at the odds, we could build our own strategy table. Right? Does that make sense? So we can look at and say what wins the most often or what loses the least often is generally what it's going to be. What loses the least? Right? Because that's the goal. We want to lose the least amount of money. Because anytime you play blackjack in a casino, you're likely to lose money. Right? Most people will lose money playing blackjack at the casino, because otherwise they wouldn't offer the game. Right? So that's part 3. So we're going to simulate I can't spell, 100,000 hands, tracking their starting hand value, randomly pick hit or stand, track the win, loss, and draw result. At the end, display the table showing the results, hitting a standing for each starting value. That make sense? Sort of? Right? So when we build these things as classes, we want them to be independent of input. Right? That way we can build the actual game for part 2 where they can play. Another part of our code will ask for user input, and then it can call the blackjack class and say, okay, for this hand I want to hit or this hand I want to stand, and then I can figure out win, loss, or draw. Right? And then I need to be able to simulate as well. I need to just do 100,000 hands and I'll randomly pick the hit or stand action as I go. Okay? So let me build out the rubric for this. Excuse me. This is our final project. Now, I do have a couple specific pieces here. This will be a little bit new here. New criteria. So part 1 is 10 points. Part 2 is 10 points. Part 3 is 10 points. And you will actually get 25% of your points here for having commits. This will be like substantial. So you can't just like change one line and call that a commit, right? So the idea here, you're getting points for doing this incrementally, right? If you just do it in 3 parts, like all of part 1 is 1 commit, all of part 2 is 1 commit, all of part 3 is 1 commit, we're not going to get all the points here, right? Honestly, one of the reasons I'm doing this is to encourage you to work piece by piece by piece by piece by piece. Another one is to make sure you don't just go ask ChatGPT for a solution and copy paste it in, right? It's hard to give me like actual substantial Git commits if you just copied from ChatGPT. It's pretty obvious. If people are like, hey, where's the solution? I'll just give you 1/10 of it every time. That's really obvious. So like, we're not going to do that, right? Because we're going to do our own original effort. You can use pieces. That's perfectly fine, right? You want to go find, hey, here's how I would calculate the value of a hand. Go for it. Cite your source. We're cool, right? Cite your source if it's not your code. Okay? Just like an English paper. But just like an English paper, you can't give me one giant quote and say, here's my paper. Right? You've got to be at least half of your own work. I don't know what English profs tell you nowadays, but I'm sure there's some percentage, and I'm going to say 50% has to be your own work. Right? If you want to cite the other half, go for it. Right? I'm going to use the pieces, I'm going to put them together to do cool things. That's what we'll do in the real world when you're building software in industry. I think the most recent survey was like 80% or more of devs are using AI tools. Great. We're going to use stuff to make us more efficient. But we still need to know how it works and know how to put the pieces together. So 10 points just for doing your 10 commits or more. Right? Part 1 is 10 points, part 2 is 10 points, part 3 is 10 points. That make sense? All right. Awesome. So I got that set up. We finished out stacks and queues already. So when we come back on Tuesday, we'll do searching and sorting. We actually pop back into Zybooks for this one here. Again, we're just doing the basics of searching and sorting, the easy ones. We're not going to deal with any of the complex stuff. You'll get into more of that later in like 350. So I don't think this will take us the entire time. So we'll have some time to get started on the project. We also got to talk about the Project 3 solution. So that'll probably take a good half hour or so. I've done this one several times, so it goes pretty quick to solve. But then we'll go over searching and sorting. We'll have a little bit of time for the project. Next Thursday, we'll also have some time to work together. So if you do end up buddying up with someone, great. You'll have a little bit of time to work with them in the mornings. If you just work on it yourself, we got a little extra time to work on it in the mornings. I can float around and help. Should be fun. And then 416 and 418 just set aside for you folks to work on the final project. Extra time there. Should go pretty good. I think we'll have our last lab probably on 4.9 because I think we can get into the streams and ethics. We might have a quick lab on 4.16 on ethics actually, but that'll probably only take like 20 minutes. So most of the lab time on 4.16 we can also work for the final project as well. And then hopefully you can get it done by the 18th, right? That's like what, 3 weeks from now. If not, that's okay. You've got till the 23rd, but ideally you have less stress for finals for this class, and you can focus on your other finals. That's sort of my goal for you. Okay, so we'll have a little bit of time each of these weeks, each of these days to work on it as well. So, encouraging you to get your 10 commits in over the next 21 days. Right, doing a little bit of work, a little bit of work, a little bit of work, a little bit of work. Okay, that should go pretty well. Thoughts, concerns? Yeah.
Tell us specifically what classes to use for Blackjack if we don't really know that much about it?
I mean, any way you write classes will work, right? But so when we design classes, we want to think about how we want to use them as well, right? So anything that's a noun could be a class, and we want to think about the methods of the functions. So
would the deck of cards be?
Yeah, you could have a class for deck. That's really easy because then deck can manage all of those things about itself. Right, or the shoe, right? We're going to put together 6 decks of cards. We're going to take cards out of it. When it gets to be less than 100, we just shuffle it back up. Right? That could manage all of its own logic in its own little class here. It works out pretty well because if we're doing 100,000 hands, you don't want to have to try and manage that somewhere separate. You just want it to happen. Like when you ask it for a new card, it should give you a new card. If it gets to less than 100, it should shuffle itself up. So you never need to know necessarily when it shuffles. You just always ask it for new cards, and it will never run out if it does the shuffling itself, right? So that makes it easier for us to use later on, if we think about it that way, right? When you think about the things we would interact with it, well, the player really only has 2 choices. They can hit or they can stand. So we need some way to tell whatever class we're gonna write that the player wants to take another card or the player wants to stop, right? Once the player goes over 21, they've lost. If they stand, then it becomes the dealer's turn, and we see who wins, loses, or draws at that point. So we need somebody to communicate that we win, lose, or draw, right? Because will go for the manual game, and it will go for the simulation, the result of win, lose, or draw. So something in here needs to be able to tell us what was the result, and then we can start a new round, get new cards, those sorts of things. So there's lots of different ways you can design it. There's not necessarily one right way, if that makes sense. All right, awesome. I'll stop recording.